Episode 12, Star Sky. Let's recap the problem statement. There are n stars on a coordinate plane. Each of them has coordinates and some initial brightness, which is at most c, where c is the global limit on brightness of a star. The brightnesses will change with time, and if at some moment t the brightness of a star is x, then at the next moment t plus 1, it will change to f of x. So depending on current value x, it will change to either x plus 1 if x plus 1 is at most c, or if it is bigger than c, so the star cannot have that value of brightness and it will become 0. We need to answer Q queries. The total brightness of some subrectangle of the plane at some time t. And here total brightness is the sum of brightnesses of all the stars that are in that subrectangle. Number of stars and number of queries is up to 100,000. The limit on total brightness c is at most 10. The coordinates are at most 100, and the times in queries can be very big. On the left, you can see some example. C is equal to 4. Here we have some stars as black points and their initial brightnesses in red next to them, and we have 3 queries. So in the first query we ask to calculate total brightness in this rectangle at time 0. We know the brightnesses of all the stars in at time 0, so we just sum up the brightnesses of the stars that are in that rectangle. So we have 2 plus 0 plus 4 plus 2, which is 8. The next query is this rectangle at time 1. So to calculate brightnesses at time 1, we need to apply function f to all the stars that are in that rectangle. So it will be f of 4 plus f of 2 plus f of 2 plus f of 3, and 4 plus 1 will be 5, but 5 is bigger than c, so it is 0, and for all others it is x plus 1, so it 3, 3 and 4, and the sum is 10. And for the third query, in the orange rectangle there are no stars, so their total brightness will be 0, independent of the time at which we will look at that rectangle. So the statement looks kinda scary. Like, there is a lot of things going on. There is two-dimensional problem, and we also have time. The numbers are changing with time, and we asked to answer some queries on rectangles at given moment of time. There is a lot. But we shouldn't be scared. Let's first try to understand how the brightnesses changes. So f of x is basically just increment, but if we move out of c, then like c, instead of becoming c plus 1, it became 0. And it looks kind of similar to doing increment modulo c plus 1, and it's exactly that actually. So f is just increase the brightness by 1, but modulo c plus 1. So if we do it t times, which is how we would calculate the brightness at time t, we should just increment the initial value t times, but modulo c plus 1. So it will be ci plus t modulo c plus 1. But then we know that to calculate that, we can first take t modulo c plus 1 and then sum them up and take modulo c plus 1. So from t, we only care about its remainder modulo c plus 1. But c is very small, so the number of different values t kind of is just c plus 1. And we can try to prepare to solve a problem for times that are at most c. And then we will be able to answer all the queries by first taking t modulo c plus 1. And let's just try all the times. And for fixed time, we just have stars. For each of them, there is a current brightness. So we just have not changing values on the plane, and we are asked to calculate sum on rectangles. That is two-dimensional prefix sums. So we try c plus 1 values of t. For each of them, we calculate current brightness for each star, and then we have to prepare prefix sums on two-dimensional grid, and that is done in time proportional to square of the area of that grid, which is a square, where a is limit on the coordinates, which is 100 in this case. And then we will be able to answer each query in constant time. That's the solution. We can think about it in a bit different way, and that way is simpler to me. Maybe it will be simpler for some of you. We can say that if two stars had equal values of Ci, which is the initial brightness, then if we look at those two stars at some other moment of time, at moment of time t, they still will be equal. They change the same. So if we group the stars by their values of Ci, then all of them will have the same value of brightness at any moment of time, and for each query among that. And there is only c plus 1 different values of initial Ci. So let's look at all the stars with given Ci. And let's try for query calculate the number of such stars in the query rectangle. Then we would be able to calculate the answer like that. We try all the brightnesses, we calculate the number of stars with that initial brightness in the rectangle, and for each of them, their brightness at moment t is apply function f t times 2x. We know that it's x plus t modulo c plus 1. You kind of still need to understand that with that solution, but you don't have to start with it. You can first write it like that, and then say, okay, I need to be able to calculate the number of points in subrectangle, which is still two-dimensional prefix sums, and I need to be able to understand what will be the brightness of a star at moment t if initially it was equal to x. So if we do all that, it works. It's a bit slower for query. Like now, for each query we have to try all the values of initial brightness, and there are a few of them. But we can spend less on n if we just group all of them at the same time, like just going once through all the stars and just put them in group for the SI right away. Then we do that in linear time. Then for each SI we need to calculate those prefix sums to be able to answer number of points in subrectangle. So it's C times calculate prefix sums, and then for each query calculate the sum of C plus 1 values. Just a different way, might be easier for some people. Well, in this series I like a lot of times there was a situation when like we solved the problem for the limitations that are in the statement, but like we can do better. But for easy problems, better is simpler. Like if you can make it a bit slower but still good to get accepted, it's a win for me. And what that problem teaches us, in my opinion, is, well, first of all, that even if the problem looks scary and there is a lot of moving parts, a lot of things going on, you still need to try to unravel it. Maybe it's not that hard. This is a fairly easy problem, I would say. And the other very important thing is that you need to look at all the limitations that you have. Like, if you just look at this and ignore all of that, it looks like we have 100,000 objects and 100,000 queries, and they're like on a plane, and there are some updates with time, and there is actually like a billion of updates because time can be up to a billion. So it looks like impossibly hard. But the actual important limitations are these. For to be able to have this in our complexity, we need small c, we need small coordinates, and we do have them. So do not ignore the limitations, not on the size of input. Like n and q are kind of size of input, right? Like number of stars, number of queries, but those other limitations are also important, and if they're small, you should think about like why they're small, how can I use it. And since like I guess this video is targeted at more like beginner level. Um, let's talk about what is two-dimensional prefix sums and how to do them. So in one dimension, just to recap and try to construct like something similar for 2 dimensions. In one dimension, prefix sums like the thing when we have an array and we want to be able to calculate sum on segment, and we do not have any updates to the array. Then we say that we can calculate sums on every prefix, hence prefix sums. And then to calculate the sum on this segment, we say that okay, let's add all the values like here on this prefix. But then we added values here that we shouldn't have added. Well, let's subtract them. So the sum on this segment is sum on prefix till the right hand point minus sum on prefix till the left hand point. So for two-dimensional prefix sums, we want to calculate the sum on rectangle, and we want to understand like what can we precalculate to do that. So let's try to do something similar, right? Like we want to add this rectangle, and well, it seems reasonable that like we want to precalculate like sums in some kind of like, for each cell, sum on all cells that are like kind of closer to 0 from it. So for each cell we will precalculate the sum on this kind of figure. And so when we want to calculate the sum on rectangle, we first add everything up to this corner, but then we can see that we have wrongfully added this figure. Let's try to remove it. How to remove it? Well, let's try to subtract this one and subtract this one, but then we have like for this part we have edited but then subtracted and subtracted again. So in total we subtracted it once, but it shouldn't matter at all, so we will add it back. And so the sum on this rectangle is like sum on the green zone minus sum in the red zone minus sum in the pink zone and plus sum in the cyan zone, like this. So if we calculate all of that, functions that calculate the sum on rectangle with like corners x1, y1 and x2, y2 will look like this. So it's green thing prefix of x2, y2, then minus red thing which is prefix x1 minus 1, y2, like it is to the left of our rectangle. Then similarly by other coordinate for the pink thing, and then we need to add back the cyan thing which is prefix x1 minus 1, y1 minus 1. But how to precalculate those things? Well, it's kind of similar. Let's look at this small picture. And for this sum in this figure, like we will need to add this cell, and let's try to reuse the values that we have already calculated. So we add this, but then we have added this zone twice, but we only need to add it once, so we subtract it back. So to calculate those prefix sums, we will do like force by x and y, and prefix sum in xy is like value in the cell plus prefix sum for this corner thing for this corner thing, but then minus the red one. So that's two-dimensional prefix sums. Kind of useful thing. That's it for episode 12. Thanks for watching.